All right, so let's take a look at the last section of chapter 3-4. Now, right here, I called it E, but I think on the homework, we call it C, because this is the third homework, but it's the fifth time that I've done a lesson on this, okay, or a video on this. That's why I called it E. So when you talk about slopes, let's think about what a slope is. Like in the real world, if you talk about a slope, what comes to mind? If you're talking about going up a slope, going down a slope, ice skating, is that what you said? Oh, skiing. Ice skiing? How about you ski on the ice? Do you? Sometimes I have. When it gets kind of wet out there and it freezes, it does ice. But snow skiing, absolutely, okay? You talk about the slopes, all right? So you can go up a slope, you can go down a slope, correct? It's and so you have has anybody ever gone skiing before? Like snow skiing to a ski resort? So they have signs, and they have green, they got blue, and they have black. What does that mean? What does that tell you? It's a system. It tells you how hard it is, okay? Or what the mountain is. How steep the mountain is, okay? 28. Who, me? Yeah. No, it's not on my YouTube. But I can ski pretty well. I don't ski that often, but I can go pretty fast. I'll tell you one story. I was going down this one hill. It was a senior class trip. I think we were in Virginia. Yeah, and this girl, no, it wasn't. It was in Canada. We actually took a... All right, I'm done. I'm not going to tell you the story then. So slope... No, you guys aren't listening. Forget it. Okay, the slope describes the steepness of a line. All right, it's the steepness of a line, and it also tells whether it rises or it falls, and if it rises to the left or rises to the right. Okay, so steepness tells you a lot of things. That's what the slope is. We're finding out how steep a line is. So if I had a line that looks like this, that has a different slope than a line that looks like this. Okay? Think about being on a slope, on a hill. All right, whether you've gone sledding or skiing or just climbing up a mountain. Okay, that's what I do, and I do have videos on that, as you know. So climbing up a mountain like this is a lot different than climbing up a mountain like this. Would you agree? All right, this is a lot steeper than this one, and this is going in a different direction than this one as well. So all those things are going to be shown in math through numbers and through... It's going to be shown through numbers and through the sign, positive and negative signs. Okay, so let's just talk about these two right here. If you're looking at this, okay, here's me, right there. Put a big fat belly on me right there. So I'm still trying to get rid of my belly. I'm skinny everywhere else except my belly. That's what happens when you get old. So watch. If I go from left to right, okay, from left to right on this screen right here, am I going up the hill or am I going down the hill? I'm going up the hill. So from left to right, listen to me. We gonna what? What? Go. From left to right, I'm going up the hill. Okay, so we call this a positive slope. All right, or just positive. Okay, let's see if I can draw sideways. I am a terrible, terrible artist. There I am. I lost some weight, so I didn't put the belly on. Okay, so from left to right, I'm going what to this slope? Going what? Going down the slope. So what kind of slope would we call this? Call it a negative slope. All right. And again, if we're talking about going from left to right, we're going up, we're going down, so this would be a negative slope, and you'd put a minus there to show negative. Wayne, turn around, face front. Nadir, I don't need it. I don't need it. All right, with that said, let's put another line in here, and we'll talk about this. Put a line about like this. Okay? What I'm going to do is I'm going to go from one point to another. That's why I said at the beginning, ordered pairs. Okay? You have two ordered pairs for distance. You have two ordered pairs for midpoint. You're going to have two ordered pairs for slope. So if I go from this point to this point right here, okay, and I can't go diagonally. Okay, I cannot move diagonally. Think of it as being on a grid, like on a graph, a Cartesian coordinate, right? Rectangular coordinate plane. If I want to go from one point to the other, I can only go up and down, and I can only go left and right. So if I start from here, let's do this in a different color. If I start from here, and I want to get to this point, I can only go left and right, and I can only go up and down. So which way would you want to go if you're right here? Are you going to go down? Okay, this one right here, this bottom one. See this bottom one right here? You see it now? Okay. See this one right here? I want to go from here to the top point up here. But I can only go left and right. I can only go up and down. All right, so I could go right. Okay, I could go to the right, and then I could go what? I could go up. Would you agree with that? All right. Or I could, if I wanted to, let's do it in a different color. I could go, what's another way that I can get from point A? Let's just call it, instead of saying this point, that point. All right. You could go, let's try change colors. Go ahead, say it. I could go up, and then does that look like it hits pretty close? And then I could go to the right. I was close. We'll pretend I hit that point exactly, okay? Now, what we do, see these ones that go up and down in the slope world? We call this the rise. So if I start here, I'm going up and I rise. Now, is that positive or negative? It's positive because I'm going up, right? So that would be a positive rise. And then I go where? To the right, and that would be, is that positive or negative? That would be positive as well. Okay, so this is positive, and this is positive. And we call this the run. All right, so when we go left and right, we call it the run. When we go up and down, we call it the rise. Now, in order to find the slope, how steep it is, okay, I'm going to write this down. We show it like this. We compare the rise and the run to each other. So I'm going to compare the rise to the run. All right? Let's say the rise was 3, and let's say the run was 7. So what would the slope of this line be? It's the rise over the run. So what was the rise? Positive 3 over the run. What was the run to get from here to here? It was 7. It was a positive 7. So this is the first time that we found the slope. You might have done this in Algebra 1. Did you guys do this in Algebra 1? Probably. It's a very Algebra 1 type topic, okay? You should have done this in Algebra 1. But if you didn't, that's okay. I'm teaching it from scratch, okay? So you can't say, well, he always says you should have done this in Algebra 1. But I'm teaching it like this was Algebra 1, okay? So this is a rise and this is a run. That's your slope. So what does our answer look like when we have a slope? It looks like a what? A fraction. Exactly right. Okay? So the slope looks like a fraction. Even if it came out to a whole number. So for instance, let's say this wasn't 7. Let's say that was 9 instead of 3. So what would the slope be equal to? It's the rise, which is 3, right? It's from point A to point B. The rise is 3, and the run, in this case, I changed it. What is the run now? It's 9. Actually, I should have done it something different. We'll do it on another line. So do I just leave it 3 over 9, though? I always reduce. Always reduce it. That's 1, and that's 3. So what's the slope then? It's 1 over 3, okay? So that's how you find the slope. Let me show you one other thing. For some reason, they use the letter M to represent slope. It's kind of weird. I looked it up one time. It's been several years since I've looked it up. A bunch of years, actually. and they don't really come to a conclusion on why they use the letter M. It goes way, way back. I mean, probably thousands of years, literally. It goes way, way back. And I think most people kind of agree it maybe came from some Latin or Greek word or something like that kind of stood for mountains. So the way I like to look at it is M kind of stands for a mountain because a mountain's got slopes, right? That's not exactly right. So if you looked it up on Google or something, it probably wouldn't say definitively that. But as far as I'm concerned, it helps me remember it. You could think of the M stands for a mountain, right? It has a slope. So M is slope. And that's the letter that we use to represent slope. So I wouldn't normally just write out the word slope. I would use M equals 3/7, okay? Now, what about the yellow one? I could, if I start from A, I have to rise then run. So I get from A to B, I could rise then run. What if I was going to go from B to A? Then I have to, it's still rise over run, okay? Let's go back to this being 7 again. Is that all right? So what is the rise from B down to here? What would the rise be? It'd be -3 this time. Do you see that? Because you're going down. So from here, right, I'll put an arrow. So if I'm going to go from B to A, I'm just going to show you something. I'm going to show you that the slope, it doesn't matter if I go from the bottom one, Jake, it doesn't matter if I go from the bottom one to the top one or the top one to the bottom one. The slope is still going to be exactly the same. Right? Because the steepness of the line does not change just because I'm going from one point to the other. If I start at the bottom of the mountain and go up to the top, it's just as steep. The mountain is just as steep as if I go from the top down to the bottom. Okay? So if I start from here, the rise is -3 and the run would be what? It'd be -7. So watch what the slope is. To go from B to A, the rise would be -3, the run would be -7. But does that make any difference on what my answer is here? Does this make any difference on what my answer is? No, because what's negative over negative? It's positive. So look, I get the same exact number no matter if I go from the bottom one to the top one or if I go from the top one to the bottom one. It doesn't make any difference. All right, you still get the same exact answer for the slope. Because I'm here and I'm going to the left. Going to the left, you go negative. Okay? Going down, you would go negative. Going to the left, you go negative. So direction makes a difference. Because I said I'm starting at B and I'm going to A. So in order to do that, using rise and run, I'm going to go down, which is a negative rise, and then I'm going to go to the left, which is a negative run. That's why it's -3 and -7. Yes? Just ask it. It's fine.
But what are the units for?
There's really no units, okay? There's no units at all. It just tells you how steep it is. That means for like every 3 feet you go up, you go what? 7 feet across. That's basically what it means. Does it mean the length of the line is always 3/7? No, this line right here, it's infinite. Exactly right. This line, if I could grab it, that keeps going, doesn't it? Whoops. Why did it do that? Boom. There we go. And let's see. And it keeps on going. For some reason, I can't grab onto it. What's going on? Hold on. There we go. Okay. See, that line keeps going. It doesn't mean that you only go up 3. It just means for every 3 you go up, you go what? 7 to the right. Okay? I could go up another 3, then another 7. You see that? I could go up another 3 and another 7, and it would end right on that line right there. So that's, and that's the same thing, right? I go negative. So I think what you're asking is this. What if you had a slope that looks like this? I don't know what I'm doing. There we go. What if we had something that looks like this? We'll call this C and D just to make it different, all right? If I wanted to find the slope of this, well, I start here, and I rise this far to, I don't know, does that look like it matches up? Close enough? Yeah, it's not too bad. It's not exactly, but it's close. We'll just put a big old dot right there, okay? So this would be the rise, and this would be the run. Now let's take a look at this. Now remember, from left to right, we're going downhill, aren't we? I want to show you how it works with the slope. So if I go from C to D, then this rise is what? I'm going down. So this rise would be what? Negative. Now I'm here, and I'm going to go to the right. That run would be what? Positive. So rise over run would be negative over positive, which is what? What's a negative divided by a positive? It's a negative. Okay, so this is a negative slope, just like we talked about at the very beginning. Okay? Let me do a couple other things, and we'll do some ordered pairs, and I'll show you a formula. Okay? I'm just trying to show you what the slope means. I could just sit here and just say, here's a formula, here's how it works, just use it. Then you wouldn't know anything about what the slope really means. I want you to understand what the slope means. It means the steepness. Okay, I think that's important. You may not think it is, but I think it is. Yes, Rosalind. Okay. What if I had a slope like this? Now, when I went skiing, there's a bunch of places like this. It's just flat, all right? Now, it's not very exciting when you're going downhill skiing on a flat surface. You got to use your poles, you got to push, right? So what if I was right here and I wanted to get to, we'll call this X and call this Y. What if I wanted to go from X to Y? Let's do rise over run. So how far up would I have to go? I go 0, right? So I'm going to write slope equals, and then I'm going to write rise over run. Okay? If I go from X to Y, I go 0 rise, and then I go whatever the distance is, okay? Let's just make one up. Let's just say it's 7, okay? Now, what is that? What's 0 over 7? It's 0. 0 divided by anything is 0. So what is the slope? This is a horizontal line. So write this down. So if you have a horizontal line, what is the slope of a horizontal line every single time? Doesn't matter how long the line, doesn't matter how short the line. It's 0, okay? I think of it this way. Let's go back to skiing again. If I'm there on a flat surface, okay, I'm on this floor right here, and I got skis on, right? And I don't push or anything. There's no wind blowing. It's not going to blow me down the slope or anything like that. If I just stand there, how fast will I be going? I'll be going 0 miles per hour, wouldn't I? I'm not going to move. How far would I go? I'd go 0, right? Unless somebody's pushing me. But if I'm just standing there, okay, I would go 0. So when you have a horizontal line, that's the way that I remember that the slope is 0. All right, so we've had a positive slope, we've had a negative slope, we have a 0 slope. What other kind of line have I left out so far? Well, we're not going to do a curve on this. These are lines. These are straight lines. Okay, vertical line. That's right. So let's talk about that. And I'll give you a little story if you guys can handle listening to a story without talking so much. Okay, and we'll call this, I don't know, MN. All right? I want to find the slope of this line. Well, I'll tell you what, instead of writing M, just so it doesn't confuse you, I'll write slope. Slope equals the rise over the run. Rise over run. And we'll say the length of that is 7. If I want to go from M to N, should have picked different letters, shouldn't I? They sound too close to the same. Anyway, if I go from M to N, how far do I rise? 7, right. Or in this, if I'm actually going from M to N, it'd be -7, but it's 7, okay? I'll just put a negative since I'm going down. Now, once I get to here, how far do I have to go left and right to get here? I go 0. Now, what's 7 divided by 0? Is it? You got a calculator? Is it? Who's got a calculator? Jake, you got a calculator. Put it in there. Put 7 divided by 0. Put it in a calculator. What's it say? It says error. It says error, okay? So you cannot divide by 0. So we say that it's undefined. Okay? That's a fancy math way of saying it. Okay, we say that the slope is undefined. Or you could say it has no slope at all. No slope is different than 0 slope. Okay? 0 slope exists. Like I can go to a ski place and see a flat surface and stand there. And that could still be considered a slope. It's just the slope is 0. But would I ever go to a ski resort, okay, where I'm at the top, here I am again, and here's my skis, there's my legs, I don't know, I can't draw, whatever, you get the idea. All right, so you got skis right here. Will you ever, now, remember we talked about the different colors? I think green is like the easiest, then blue is intermediate, then the black diamonds is what they usually call them, is the hardest one, okay? They have single black diamonds, they got double black diamonds. Yeah, I've done the double black diamonds, and I go pretty much straight down. Well, I'll tell you real quick, the story I was going to tell you before that you weren't listening. So if you listen, I'll tell you a quick little story. So I was on a senior trip, we were in Canada, and this one girl, she skied all the time. Like, her parents had money. She was actually the girlfriend of my son for a while there. But she was always bragging about how good she could ski, right? The whole time up there. Oh, I ski all the time. I'm going to ski, Mr. Hamrick. I'm going to race you down the mountain. I'm like, okay, that's fine. I ski once every 4 or 5 years if I'm lucky. You know, I barely, you know, there's been a couple years when I might have skied twice in 1 year. You know, that's the amount of skiing that I've done. So one day we get up to the top and she's up there and she's like, yo, Mr. Hamrick, let's race down the hill. Oh, Jesus. I got to warn you, though, you know, I'm like, I know you're a good skier, blah, 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 right? So she takes off, and she's good. I mean, she really is good. But then, and she's like swishing back and forth like this, and it was a steep hill. But I was like, nah, I'm going to beat her. There's no way I'm going to let her beat me. So I just start going straight down without turning back and forth, and I just went right by her, and I just kind of waved as I flew by. She goes, that's not fair. You were, I'm like, hey, you said you're going to race. That's the fastest way down, right? It's straight down. So I did beat her. So I'm very proud of that fact. So, and she skied all the time. Like every weekend, her parents would go to Poconos. They go skiing all the time. So anyway, and I didn't ski that much. But when you, when I got down to the end, I stopped. Yes. So anyway, as steep of a hill as I've ever skied down, I have never, ever gone down there's no place in the world, no matter how difficult it is, where it's absolutely vertical and it's straight down. There's no way that they would ever have a ski slope, okay? It doesn't exist. You see where I'm going with this? It doesn't exist. So the slope of a vertical line, what? It doesn't exist. There is no slope that exists that is vertical. Okay, you with me on that? All right, I'll tell you another story. Ready? Yeah. Pretend this is me again, but I started up here. This is not skiing. I was in college. I was in ROTC, which is kind of like if you want to get in the military or something, you go in ROTC. And I thought I was going to go in the Marines. I was all gung-ho and stuff. So I joined ROTC, and we went out to VMI, Virginia Military Institute, which is kind of like West Point or the Naval Academy. It's one of those places. It's out in Virginia. Virginia Military Academy or Institute. So anyway, we get out there, we're going to do rappelling. I'm like, that's pretty cool. And we made our own little, because they hook you up with these ropes. It's just a straight rope. And they show you how to twist it and bend it and put it around you. They call it a Swiss seat, I think. Anyway, so you're all good. And we went down this little this little slope about like that. I mean, I could have walked down it. Would have been no big deal, right? But they just wanted you to get used to it. So you take a rope and you put it around your back, and that stops you. If you come out like this and you let up, it lets up the slack, and you can just go boing, 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 and you just go down the hill. And you're going backwards, right? You're looking up the hill, and you're going backwards like this. And so we practiced on a slope like this. Wasn't that big of a deal. Wasn't that exciting. Again, I could have walked down it. Wouldn't have been a problem. But then they took us to this place, all right? And it was sheer rocks. It was just completely straight up and down. There was no slant. There was no slope to it at all. It was completely straight up and down. At the bottom were all these big, huge boulders, these big, gigantic boulders at the bottom, right? And so people were going down, and they would get to about this point when you're like perpendicular to that, right? There's a geometry word. When you're perpendicular to the mountain. And then they said, okay, now you can start going down. So your feet are up against the wall. Your head is out here like this. You follow me? All right, so you're like this. So at first you're like that, and he's like, let down, let down, let down, let down, let down, until you're perpendicular, and then you can go. And then what you do is you let out a little rope, and gravity just takes over, and you go like this, and you go like this, and you go like this, okay? So 4 or 5 bounces, and you're at the bottom. All right, and it looks fun. Everybody was doing it. I thought I could do this. So I get up there, and he's like, let out a little more, a little more, a little more. I swear I was perpendicular. I know I was. And the guy kept on saying, no, let out a little more, a little more. And I'm going down like this, down like this. Yeah, exactly. Okay, and what happened? I went, yeah, boom, just like this. Okay, my head is facing straight up. So here, let me try to draw this. Okay, so my head was down here. I was like this, all right, and my arms were like that because I was holding on to the rope. I was completely straight up and down. My feet were above me. You should have seen all the people up here. All these people come running around, looking over top of that, and I'm upside down. I'm completely upside down. So I see everybody on the top of the hill, and there must have been 15 people that just kind of ran and were like looking over because the guys that were in charge, the VMI guys, they're like, don't move, don't move. They're freaking out, don't move. And as soon as everybody heard that, everybody wanted to see what was happening. So they came around. Here I am, straight up and down like this. I was like, oh, and I wasn't even scared. I mean, I should have been scared, but I wasn't because I was more embarrassed than anything. I was just so embarrassed. And so I was like, there is no way. They're like, don't move, don't move. I was like, there's no way I'm going to let these dudes rescue me, right? In front. I mean, there was girls there. I was going to get rescued in front of girls, right? And so I started, so I was like this, right? And I was like I was trying to bounce a little bit off the wall. And finally, I got my feet up under me and I got like this. They were like, no, 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 don't move, don't move. I was like, forget that, right? And I went boing, boing, down to the bottom. And I made it down so fast. Everybody took like 4 or 5 turns. I went bang, bang, and I was down there at the bottom. And the guy down the bottom, like holding the rope and all that kind of stuff, he's like, man, it took you a while to get down here. He says, but once you got started, you were the fastest one down here. I was like, yeah, I wasn't going to stay up there and get embarrassed. He says, nah, you were fine. But that was my slope story, okay? So that's going down no slope, all right? And I still survived. And I still was embarrassed though, but that's it. So that's my story. I got 5 minutes, so let's do a little formula, and I'll show you the formula. Fallen? I have not done that. No. Yeah. I've been right behind other people that have fallen off the ski lift, but it probably was Bryce. No, the last time I went skiing, I don't even know if you were born last time I went skiing. All right, here we go. Let's take a look at this. That was supposed to be red. Why wasn't it red? There it is. All right, guys, here we go. So what I'm going to do, we're going to come up with a formula. Let's listen now. Listen. We're going to come up with a formula for slope. So I'm going to put a point here, and I'm going to put a point here. So what I want to do is I want to rise and run. So this is going to look very familiar. It's kind of like what we did earlier. So I'm going to rise to about right there. Let's see if I guessed right. And then, yeah, it's close enough. All right. So watch this. This is the rise, and this is the run. But we're going to do, we're not going to call this point A and B anymore. I'm going to call this point 1. So this is going to be what? X1, you've seen this before. Y1. What are you going to call this point down here? X2, Y2. Okay? Now watch this. I'm going to write rise and run in terms of X1 and Y1, X2 and Y2. You hear what I'm saying? Candace, please. I'm going to write the slope in terms of X1, Y1, X2, Y2. Forgot the 2. So if I go from here to here, how far is that? Well, that's the distance of the y's, correct? So it would be y1 minus y2, right? Because I'm going from one y point down to another y point. That would be the rise. And then I'm going to run over from x1 to x2, right? This would be underneath x1. Do you see that? And then I'm going to run to x2. So what is my run then? It would be x1 minus x2. Everybody see? So now I'm ready, just knowing that and all that stuff that we talked about, just knowing the x1, y1 and all that kind of thing. Why did I put a minus there? I didn't mean to do that. I think I meant a comma. There we go. All right. Did it here again. What was I doing? There we go. All right, so now let's write a formula for slope. I put m, but you know that m means slope. So here it is. It's the rise over the run. So what am I going to put? Oh, I know I put that. It's a minus, of course. That was dumb. I shouldn't have put a comma. I don't know what I'm thinking. Sorry. Now watch this. The slope is the rise over the run. So what did I call the rise as far as the x, y, and y ones are concerned? I call it y1 minus y2. What is the run? What did I call the run? x1 minus x2. That right there is your formula for the slope. Whatever's in the box, that's what you need to memorize. Now, I will tell you that this book and a lot of other books write it like this. They'll write it y2 minus y1, but that's fine. You can write y2 minus y1 as long as you do what to the x's, do you think? Right, make that x2 minus x1. So as long as you put them in the same order, then you're good to go. So let me give you an example, and then that'll be it. I'll give you one example. This is example 4, and it's in the book. Yes? I don't have enough time. I have to do this. So here's what I'm going to give you. I'm going to give you 2 points. This should look familiar to you. Okay. So I'm going to ask you to find the what? The slope. So let's do it. So watch. What's the slope equal to? Yeah. So it doesn't matter if you put the 2 or the 1 first, as long as on the x you do the same exact thing. Okay, we're showing you how to do the problem. You guys are packing up. This is not the time to pack up. Let's look up here. I'm showing you how to do this problem. I'm going to give you homework on this, and now is the time where you decide not to pay attention. That doesn't make sense to me. So look, over here, this would be your x1, this would be your y1. This would be your what? X2, and this would be your y2. We've done that a couple times. We did it with distance, we did it with midpoint. It's the same kind of thing. Okay, but the formula is different. So we just subtract the y's from each other. It doesn't matter which order we subtract the y's, as long as you subtract the x's in the same order. Did you hear me? That's super important. I'm going to say it again because some of you are not paying attention and listening. It doesn't matter what order you subtract the y's, as long as you subtract the x's in the same order. Okay, so I could go -4 minus 2, or I could go 2 minus -4. It just depends on the x's. You got to do it in the same order that you did the y's. So let's just do the first one minus, let's do it like this. We wrote y2. What's it going to be? 2 minus -4. Let's subtract the x's. It's 3 minus what? No, 1. Subtract the x's. That's an x, and that's an x. Okay? That's all we did. We subtracted the y's, we subtracted the x's. So what'd you get? 2 minus -4. What's that? No, it's positive 6. Okay, 3 minus 1 is 2. Always simplify it. What's 6 over 2? It's 3. You could write 3 over 1 if you wanted to, or you could just say it's the slope. We got 30 seconds. I want to show you this. Let's subtract these in a different order. Instead of y2 minus y1, let's subtract y1 minus y2. I just want to show you it doesn't matter. So what's this going to be? -4 minus 2. And the y's, 1 minus 3. Look what we get. -4 minus 2, add a line, change the sign, that's -6. 1 minus 3, add a line, change the sign, that's -2. What's -6 over -2? Positive 3. Do we get the same answer? We do. Your homework. Don't leave. And don't tell me you didn't hear, because I'm telling you to watch. It's 3-4C. It's page 133. And it's 13 to 22. That's your homework right there.